Okay, we are finally to the end of our special functions. This one we're going to talk about tonight is called the greatest integer function, and it's a step function, so it's a piecewise, but all of the pieces are line segments. So we're going to look and discover what does the graph of a step function look like, and then how do I graph the greatest integer function, which is one of the step functions. Right. A step function is a piecewise linear function. Okay, piecewise. And it's made of segments. It looks like steps. It truly looks like steps. So the name just kind of gives it away. The domain is always all real numbers, but the range is only the set of integers. The range is only the set of integers. So you see these when you have situations where there's an hourly rate or something is charged by the minute, and then if you go into like partial hours or partial minutes, you have to pay the next full amount. So garages are like this. They would charge like $130 for per hour, and then they would charge, if they went over into the second hour, they would charge the next $130. Doctors, a lot of doctors that do like psychologists, they'll charge $85 for the first hour, and then $85 for any increment above an hour. So that's how you kind of see it in the real world. The one that we're going to talk about is the greatest integer function, and it symbolically it looks like f of x is equal to, and this kind of looks like an absolute value, but it's kind of like a double bracket. It means that the y value is the greatest integer less than or equal to the value that you plugged in for x. I know that seems kind of weird, and you're probably going like, what? But we'll do a couple of evaluations here, and I'll show you what I'm talking about. So let's start with just learning how to evaluate. Hold on, I have to cough 1 second. All right, I'm back. So if we're evaluating a greatest integer function, basically you round to the greatest integer that's less than or equal to the argument. So everything in red, that's the argument. So we want less than or equal to -3, less than or equal to -3. So that would be -3 because it's equal to. However, look at what happens at -3.25. Less than or equal to -3.25. So you'd have to go to -4. At -3.5, you want to get to the integer that's less than -3.5. So that would be -4. -3.99, you got to get to the integer that's less than -3.99, so that would be -4. Notice that we're not taking the absolute value, we're not changing it positive, all right? We're just rounding it to the nearest integer that's less than. Instead of rounding up, we're kind of rounding down. So if I were to find f of 4 in a greatest integer function, all right, that would be 4. However, when I go to 4.25, all right, well, if I go to 4.25, I need the greatest integer that's less than 4.25. Less than 4.25, well, that's going to be 4. And the greatest integer that's less than 4.5, well, that's 4. And the greatest integer that's less than 4.9, well, that's 4. And then at f of 5, we do, it pops up to 5. Here at f of -4, we would be at -4. Okay? So the popping up occurs at the biggest value. Seems weird on the negative side, I know. So here's what we're going to do. If we're looking to graph a step function, you're going to write your inputs as intervals between integers. Okay, so notice that I just randomly picked because my graph is at -5. I went -5 is less than or equal to x is less than 4. So any of those values, if I were to plug in like -4.25, -4.5, they would all round down to -5. And again, with the next interval, -4 is less than or equal to x is less than -3, they would round down to -4. And then -3 is less than or equal to x is less than -2, that would round to -3. And then -2 is less than or equal to x is less than -1. That's going to round to -2. And -1 is less than or equal to x is less than 0. It's going to go to -1, and so on, and so on, and so on. So let's go ahead and try and graph these. So between -5 and -4, I'm at -5 on the y value. Here's my y is -5. Here's -2. Okay. Here's 2. Here's 5. Okay. So anywhere between, on my x's between -4 and -5, I have to keep it, my y value at -5. Between -4 and 3, and it's closed at -4 because that one is associated with the inclusive, to -3, and that's open, that's going to be -4. And see how we start getting a step here. And then we go from -3 closed, and then open at -2. Whoops. And then we go from -2 closed, x is -2 closed, x is -1 open, that's at -2. And then we go closed from -1, and then we go open at 0, and then we go closed at 0, open at 1, and then we will go closed at 1. You see the pattern that's just building, and open. This one's kind of tricky. Okay, I'm just following the pattern right now. Closed on the left, open on the right, and then I'm just going all the way up. Okay, and it makes kind of a stair step. We can also do it with a negative in the front. So watch what happens when we plug these in. So if I plug in a -1, I'm going to get the opposite of -1, which is 1. So when x is -1, it's closed at 1. And then it stays at +1 until I get to x is 0, and then it's open. And then I'm plugging in a 0, so f of 0 is equal to the opposite of 0, so that's just 0. So it's closed on the left, open on the right. And then if I plug in f of 1, I'm going to get the opposite of 1, or -1. So it's closed on the left, open on the right. And then I plug in f of 2, and I get -2, and then my pattern continues. The domain is always all real numbers, and the range is all integers, or z's. Here's an example based on a psychologist charging fees. One psychologist charges for sessions at the rate of $85 per hour, or any fraction of an hour. So if you go in and you talk to them for 5 minutes, that's $85. If you talk to them for 1 minute, that's $85. If you talk to them for 59 minutes, that's $85. So it's $85 for every hour or part hour. So on this one, I'm actually going to plug in the upper limit here because of the way it's constructed. And I'm going to plug in a 2. And here I'm going to plug in a 3. So this is $170. And this one is what? $255? And it would go from there. So at hour 1 and a little bit, if you go just a little bit over, you're going to be at $170. Okay? At hour 2, just a little bit over hour 2, you're going to be at $255. And then you can see how the pattern is continuing. Open, closed. Sorry my clothes look so bad. It's just this, it's the way this screen works. And then it would just continue on and on and on. So this is what we're going to work on tomorrow. I'll talk to you and see you tomorrow. Thanks for listening.